Hello my dear students, once again welcome to your online class. So today we will continue the chapter work, energy and power. So in the last class we had discussed about the work done by the body and the conditions when the work done was zero. So today we will discuss over the two topics, that is the power and the energy. So coming to the term power, so what does the power means is, the power is literally the rate of doing work. So the power, it tells us how fast the machine is capable of doing work. So the power is simply the rate of doing work, and the power can be calculated by the formula power is equals to W divided by T, where the W is the work done in the given time T. So now second, coming to the unit of power, since the power is also a physical quantity, so it can be measured with a suitable unit. So coming to the unit, the work is measured as joule and the time is measured as second. So the SI unit of power is joule per second, which can also be called as a watt. So now coming, if somebody says you, I pose a power of 1 watt. So what does that mean? It means that if 1 joule of work is done in 1 second, then the power is said to be 1 watt. Once again, it's very simple. If 1 joule of work is done in 1 second, then the power is said to be 1 watt. So now there are two factors on which the power depends. So looking at the formula, we say that the power is directly proportional to the work and inversely proportional to the time. So thus we can say that the more work we do, the more is the power, and the lesser time we take, the higher is the power. So the power is directly proportional to the work done and inversely proportional to the time taken for doing that amount of work. So another important topic here is the energy. So energy is basically nothing, but it's just the work done. Energy is just the capability of doing work. So what is it? The energy is the capability, or it's the capacity of doing work. So we can say that the one who has more energy can do the more amount of work, and the one who has a lesser energy can do the lesser amount of work. Hence hence the energy and the work, they are almost the same thing. Now coming to the unit, since energy is the capacity to do work, so hence the unit of energy and work is same, that is the SI unit of energy is joule and the CGS unit is erg. Apart from that, we also have the bigger units to measure the energy, such as watt hour and kilowatt hour. So what is 1 watt hour? So if I say somebody has the energy of 1 watt hour, so what does that mean? It means that any device or anything which is rated 1 watt and it works for 1 hour. So that is said to be watt hour. And what is 1 kilowatt hour? So any device which is rated 1 kilowatt and is used for 1 hour. So the energy spent by that machine is said to be 1 kilowatt hour. So apart from that, to measure the energies posed by the human beings, we can also use the unit such as calorie. So coming to the relationship between the calorie and the joule, we have 1 calorie is equals to 4.18 joule. And coming to the other unit, such as if we are to measure the energy of the subatomic particles or the atomic particles which are very, very small. So in that case, we use the energy electron volt. So what is electron volt? So 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. So this is what the power and the energy means. So in the next topic we have is the different form of energy. We know that in our day-to-day life we come across different forms of energy, such as the sound energy, the heat energy, the light energy and much more. Even we have a nuclear energy as well. So one of the important energy that we come across our day-to-day life is the mechanical energy. So what is the mechanical energy now? The mechanical energy is the energy posed by every body, whether it is in rest or be it in a motion. So the energy posed by the body due to its state of rest or of motion is known as a mechanical energy. Now since the mechanical energy can be caused due to rest also and due to motion also, so hence the mechanical energy are of two kinds. The first being the potential and the other being the kinetic energy. So what is the potential energy? So the potential energy is the energy posed by the body that is at rest. So everything, whether be it a universe or heavenly bodies or a large particle or very tiny subatomic particle, if it is in rest, it poses energy known as a potential energy. So the energy posed by the body due to its state of rest is said to be the potential energy. Now coming to the next kind of energy is the kinetic energy. So what is the kinetic energy? Kinetic energy is also the form of mechanical energy, but which form? It is that form which is caused due to the state of motion. So whenever a body is moving or it is in the state of motion, it poses a mechanical energy known as a kinetic energy. Here the kinetic and potential both are mechanical energy. So potential energy is a mechanical energy due to the state of rest, and the kinetic energy is also the mechanical energy due to the state of its motion. So coming to the types of potential energy and the kinetic energy, we have various kinds of potential energy and as well as kinetic energy. Like we have a gravitational potential energy which is due to the gravitational pull of the earth, and we also have the elastic potential energy which is due to the tension acting on the strings. Now coming to the types of kinetic energy, we have many forms: the translational kinetic energy, the rotational kinetic energy and the vibrational kinetic energy. So as the name itself suggests, the translational kinetic energy is due to the body moving in a straight line. The rotational is due to the rotation of an object. Whenever something rotates, it poses a kinetic energy known as a rotational kinetic energy. And the third being the vibrational kinetic energy. Whenever any object moves to and fro, it poses energy known as a vibrational kinetic energy. So the next we are going to derive the expression for the kinetic energy and the potential energy in your next class. Thank you.